Okay. Okay, so this afternoon we'll try to do that really on the scanners. So maybe we will start with a color check. Check the UTT later. So we'll apply this. So I make the color test first with color checker SD and the color module of IQ Analyzer, and then we will run the UTT. Okay, so I need first to chart straight. Okay. So when on the color chart is not it is not an issue, but when you run metamorphose, you are not supposed to apply any automatic deskew because this will have an effect on the resolution. So that means you need to first to have the chart straight. For the color, it doesn't matter at all. So let's scan it with a glass plate, maybe. Okay, save the file, and then I need to run IQ Analyzer, but here we'll run the color module. Sorry. And on this PC, as I have two dongles for two modules, and the other one we have one dongle for both. So I need to close the software, load the right dongle, and start it again. So it's IQ Analyzer. Yes. So it takes a few seconds to start. Okay, you can see there are several modules. You can have a module for color, another for shading, another for grayscale, another for resolution, and so on. So here we'll just use the color one. Okay. Then I need to say which kind of chart I want to use. So this requires a file for the chart layout, that is size of the chart, where are the color patches, and so. And this is a reference file containing the value of the chart. And then I need to load the image. So load the image. This one. And let's say here I have a choice of the color space I want to use to make the control. So suppose I select this one. Okay. I select Adobe 98. Really, my image is in ECI. So that's not correct, but just to show you. So if I run the test, so that's the only thing I have to do. I'll start the test. And sorry, I need something else. Yeah, I will start with the 76 formula. Okay, so here you see so this is delta E for each patch. So the grayscale is more or less okay. The black is a little bit high, but not so bad. But there are some patches here which are here close to 20. That's because I did not select the right ICC profile. So if you have an image in ECI and you check in Adobe, of course, it's not the correct value. So I will come back to the right color space and see what happened. So I could use this embedded profile. In this case, the software will read the profile inside the image and will always select the right one. But it is not always the best choice to do, because imagine I want to scan all my image in Adobe 98. And on one scanner, the setting is made to have the image in ECI. If I select embedded profile, I will not see there is a mistake, because the result will be okay. If I select Adobe, I want all the file to be in Adobe 98. If one scanner is providing ECI images, the result will be wrong. So I will notice there is something wrong. The image is right, I mean, it's okay, but it's not in the right color profile, so I will notice that. So it's a good habit to select directly the profile you want to check. And then I start again. Sorry, yeah. Well, in this software, when you don't just change this, it doesn't recalculate. So I need to do that, and then I can ask him to make the calculation again. Okay, and then the result is quite different. So, and it would be worse if I had selected sRGB, which is more different from ECI. So here we have the full result. So you have the average delta E. You cannot get directly from that because there are too many. So it's 2.8. And the maximum is 9.4. That means this would be okay for metamorphose. Both level, metamorphose light or even metamorphose full, because the full require less than 10 and less than 4. Okay. And okay, so that's okay. What else can we say? We can see again that the gray scale usually is correct. It's the first thing that is correct. And there are some patches which are higher. If you want to see which color it is, you can select that. And you see that, for example, here it's in the purple colors that you have a big difference, and a little bit in some green patches also. Okay. And I can also access to delta L, which is the luminance. So here the result was okay on delta E, but if it was not so good, I could check if it's come because of the light level, which is not the right one. Here all the value, you know, if you don't read the value, you can see the color. That means it's good, and this one is a little bit not so good. It may depend on the chart, by the way. And if I come back here, so this is typical result from metamorphose test. If you want to check ISO or the new metamorphose, you will have to apply this formula. And then I need to start again. And you see that the result is quite different. The average is lower, it is 2 instead of 2 or 3 something. and also this number are different, and the maximum is probably not at the same place. It's because the delta E formula has come from the 76 one. It has been modified to check better our human vision, and it gives, for example, I know it gives less weight to this color. All the green, blue colors will have less weight and usually gives a better result. Okay, so this is supposed to be more precise, more right, I would say. That's why everyone is going to this kind of formula. And if we try this formula, it will not make a big difference. We can try to see. So we have average of 2 and maximum is 6 here. With the standard 2000 formula, which is still used in FAGI, it will not make a big difference. You see, it's nearly the same, 1, 9, and instead of 6 here we have 5. It's quite the same. So in the near future, everybody will use either this or this formula. So it will be more uniform, let's say. That's the main parameter. You have another parameter here, is where to check the white point. You can take it in the profile or in the image. Usually you select the profile, and that's it. You can also, if you want, have delta C, delta H information. So delta C is the chroma, that is the distance from the neutral axis, and U is the U, so it's a color, more the color, if it's green, blue, or red or something. So chroma is if it is saturated or not. But it's not so easy to interpret. And here you get the visual noise. You get the noise, which should not depend on the color patch so much. But okay, so usually you stop here with this one, and should be the test to do. So this result is quite stable because it's more or less an average. Especially the average delta E, it's average of everything. So if you change a little bit the scanner settings, it will not change so much this result. The adjustment which will have the more effect is if you adjust the grayscale, especially the black area, you will change the value on all that and all the dark colors, so the average can change a little bit. That's it. So here again, if you come back to delta L, you can see that the white level is correct on this chart because it is 0, 3, 0, 1. It's very good. The gray is quite perfect. We have 0, and the black is a little bit dark, but still within range. So what we will do, we'll check the UTT. UTT is more precise. So usually if this result is okay, you don't know about the UTT. I mean, I talk about the grayscale. If the grayscale is okay on that, maybe it will not be correct on the UTT. But the opposite is true. If it's okay on the UTT, it should be right on the color checker SG. Because here we don't want so much precision, in fact. So just don't forget to select the right color profile, and that's it. Okay, so I need now to check the UTT, unless you have some question on that. We'll do it again on the other one anyway. This one is quite simple. So here the same, I need to have the chart straight. Okay, let's do that. Let's see what happened. I made one setting that should create a problem, but it's sure. So I save the image. I need to restart IQ Analyzer. So here what I have done, I have applied some sharpening on the image. It should not be done, so I want to see the result of that. So we are waiting for IQ Analyzer. And now I have to select the UTT module. And here I need also to select which kind of chart I have. Is it a A3 or an A0 UTT? What is the reference file of this chart? So here we have two charts. The serial number is written on the chart, so I have to select the right file. And the specification file. So here we are checking metamorphose light. There are several specification files. You have extra light, you have version 1, version 0.8, and you have the ISO level ABC. So let's start with metamorphose light. I need also to load the image. And here also I need to make sure I use the right ICC profile. And then I can click on start. As long as the image is cropped like this, the automatic cropping will work. If not, I would have to use the manual cropping if the chart is in the middle of an image. Okay, so here we have, you see one red cross on the resolution, and here you have some details, I mean the sub criteria. You see that the sampling efficiency, the MTF10, everything is okay. The problem comes from the maximum modulation. This is because sharpening filter I have applied. You see it's here, if we go to the, to reduce that. We have enlarged the screen to see it better, but okay. So if I go to the resolution display, you can see the sampling efficiency is right. This is about the same. The MTF50, so the low frequency is okay also, but the maximum modulation is too high. The color mix registration is good also. This one is too high, so we go, you see, up to 126%, which is too much. So, and this could also have an effect on noise, because sharpening will amplify the high frequency, the detail, so it will also amplify the noise. So here the noise is still within tolerances, but you will see that it will be lower when I will reduce the sharpening. So let's save the same image with no sharpening. And I will open both images. So here I will check both images at the same time. Okay, so this is still the result from the first image. You see on the second image that the noise is lower, just because of the sharpening effect. And you can already see that the noise is higher in the black area because of the gamma correction. And this is the noise on the grayscale. So here on this grayscale, at the top grayscale, you have the black patches, the white patches here. We can look how it is on the bottom one, on the left one, and on the right one. Okay, and here, again, this is probably a dust. So if I check, it's patch 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I open the image and it was on the right one. On patch 10, I should see something. Let's see. This is enough. Okay. So it's not a big issue, just have to be aware of that. And again, if it's on the glass, no problem to clean. If it's on the chart, go slowly when you clean the chart, because you can damage the chart by cleaning. And let's see on the resolution what is the effect. So you see it was like that. So we had really too much sharpening, and now we have no sharpening at all. So we are at this level. The sampling efficiency doesn't change. Here in this case we have enough sampling efficiency, maybe a small change in on this one, but not so much. So this was the main issue on resolution. But we had an issue on, small issue on delta L, on tonal reproduction. So this one we have to forget. I said the measurement is not correct. So the color is okay. It's logical because it was okay on the color checker. On this scanner, we know that the result on the color checker and on the UTT are about the same. It can be different on with another lighting. The shading, yeah, we can have a look at shading rapidly. So shading, you see it's the horizontal line, the white and the gray one, sorry, and the two vertical ones. So here it's really straight, it's okay. Maybe here also small dust or something, but it's okay. And you have the same, these are from the line on the, from this line here, there and there. And you have also the result from, called the grid, that is these patches here, the color of these gray and white patches. Here you can see, yeah, where it is measured, by the way. It's measured on this green line. So this is where they are checking the level of this white and gray patches, and also the distortion for the poly is measured here. Here you have the sampling efficiency, the color patches, the grayscale, and this line. Okay, so this was okay. Resolution we have seen. Color, so about the same. The maximum is on the brown one. Okay. Noise we have seen. So let's go directly to tonal reproduction. So again, we had an issue here. So that means the level is too low, too high somewhere. So we can see that here. So here we can see that probably, so it's a right grayscale. Here it's okay, but probably there is one at least having being a little bit outside. Yeah, this one. See at the top, a little bit too much light, and this one also. And you can see that the four grayscale are about the same. So here there is no trouble to lower the light level. So what I have to do, you can see it's a whole curve which is too high. So it will be just dropping it a little bit, just by lowering the light level. So if you want to know how much, here you can see it's close to the limit, so it should be 2L, that is 5 RGB level. I can also get the number here. I don't know if you can read, so it is here, the yellow one. We have 2.03 instead of 2, so we are quite good, but if I check the other one are also quite high, and if I go to the bottom grayscale, it is also too high, so I will just drop that. So I come back in the scanner adjustment. And yeah, the best would be okay to so it's a line scan camera, so here it's not moving, so I see only one line. So I try to put the camera on the grayscale of the chart. So on this grayscale here, on this one. So I have directly display, and I can check the numbers if I want. So I can see it is 243, 44. So I need to drop about 5 level. So to do that, I just yeah, I can. So on this scanner I can control the light level, the lighting level, or I can control here the gain, the electronic gain. So I think this should be enough. Sorry?
This program, this is the scanner software.
Yeah, this, no, here we are inside the scanner software, so it may depend on your scanner. You will see on this one, even if it's the same software, as the scanner is different, as the display will be different. Because here we have a line scanner, so we can see only the line which is under the camera. So here I put the camera over the chart at the right place to see this grayscale. But I don't see the color patches, I don't see anything. On this one, I will see the whole chart all time. So it will be easier for me to check, for example, the level on different grayscale at the same time. But this has to be in the scanner software. You must have, I mean, you should have in any scanner the way to control the light level, the black level, and everything. If not, you cannot do it correctly. So he just asked me, we have some calibration profile, so he asked me if I want to save this modification, so I will say yes. Even if I don't know if it's good enough. But, I mean, it should be here. We saw the curve was quite straight, just a little bit too high, so it should not be an issue. Okay, so if I come back here, so I will keep this one, I will delete this one, yeah, and add the new, this one. So this is the first one before the modification, and we will see the effect of the modification. So when you change the light level, the whole curve will go down, so it should be okay. Yeah, it's still calculating. Okay, so this is the result of the first image. Now we can see the result on the other one. So it has dropped a little bit, and that should be okay enough to fix that. Let's see if everything is okay on that. I mean, here it's okay. So the difference was here only. This again is random, you cannot fix that. So if I come back here, you see, just by moving the light level, you can do that. So it will depend on the scanner, but most of the time you will have access, at least at the exposure time, light level, or some gain inside the camera to do what I did. On this one, for example, I can access the light power, but it's just a button, so I don't know exactly what to do. So it's easier to do with the exposure time. On some other scanner, you may have also the gain inside the camera to change. So you should have a control on this light level. You must have also control of the black level. So if the black level is not right, you have to be able to move it. And with the gamma correction, you can have an effect on that. I will show you. So I delete the first image, and I will, for example, see you the effect of the gamma correction. So I come here. So if it is 44, if I set 46, for example. So here I just changed the gamma correction. So I set from 44 to 46. I don't want to save it. So that should give me an image with lower, the middle gray should be lower. So this is the previous display from the old one. It will be updated. Okay, so this one is the one we had before, which is the right one, and this one, you see, the black level is the same. The white level is about the same also, but the middle of the curve is lower. It's because the gamma correction is different. So by this way, you have a control of the, let's say, the top side of the curve, the middle, and the bottom. You could need more, and you could have some tools to edit the curve locally. Here I don't get that on this scanner, but that's something you may have also. Should not be needed, but okay, why not? Okay, so I will come back to the right setting. We'll do something else wrong. So, okay. If, for example, I modify this. Not too much. So you see what I'm doing here? I'm increasing the blue channel in the dark area. Okay. Quite a lot, but okay. I don't want to save. And so I will delete all that. I will just check this one. So here I should have an error on the grayscale only. On the low part of the grayscale, the color should be wrong somewhere. So the curve itself is still okay because the luminance did not change. I just changed the blue channel, so it has nearly no effect at the luminance. So the level is still right. But if I go there, I should have, you see, some problem with the delta E, that is the color of my grayscale. The level is okay, but the color is wrong. And when you get that, it's not so easy because so you have this. If you go to tonal reproduction, here you don't see this effect. You will see it in the white balance. So this is the white balance. You can see that in the white we are neutral, and when we are reaching the dark area, the balance is not good. But you still don't know in which direction to go. You don't know if it's too much blue, too much red. You have no information here. And that's it. You have the numbers, but the number, it will be the same. You have here the delta E, which is wrong, and the delta C also, but that's all you know. You know the color is wrong, but you don't know in which direction to go. That's what is interesting in this display. I talk about open dice in FATG. Okay, it's not very good to use RGB to check the balance, but when you do this, at least you have a direct information of what is wrong. Here, if the blue channel is too high, I will see it directly. Where I'm here, I don't know. So I have two options. One option is to come back to the scanner setting. It will depend on the scanner. Here it will be visible. Here I can clearly see that the blue channel is too high. So I can set a probe here, and I can see that, you see the number is 5361, so the blue channel is really too high. I can do it from here. If I don't get this information in my scanner software, I have to use some other tools like GIMP or Photoshop. So I need to open my image. It should be this one. Here also I have to take care to keep the ICC profile of the image. And then I need to, well, it doesn't matter, it's on all grayscale, I think. So if I, so here I can check the level, and I can see that the blue channel is too high. I still have to be careful because I don't know how is the chart. I don't know if the chart is really neutral. Usually it is. If I want to check, I need to open that. So this is the reference file of this chart. And on all grayscale, I have to check if in the dark area the patches are more or less neutral. Here they are. Most of the time they are. But remember that sometimes, here the white is not so bad on this one, by the way. Sometimes it could be not really neutral, so I have to check anyway. For example, if you were using the Kodak grayscale, you cannot trust the balance of the chart. So here I can say it's neutral, so I can really see that the blue channel is too high. So the solution is to come back in the scanner settings, lower the blue channel. So in this case it is here. Until I get something neutral, and here I should be back on the correct settings. So let's try. Okay, it seems to be correct. So that means you need a little bit training when you do that. You need to know, and maybe at the beginning to try like this, what happens if I do this, what happens if I do that, to understand what can go wrong. And after some time, you know directly when something goes wrong, you know directly where does it come from and what to do on the scanner. So you will rapidly know the difference between an error on the level and an error on the color, and any error somewhere else. So it looks complex like this. It is not simple, I agree, but with a little bit training, you can. Yeah, but yeah, you can spend some time to adjust the scanner the first time. Okay. After that, it has to be stable.
Not twice a day.
No. Because if it is good now, it should be good in the afternoon. It should be good tomorrow, and so as long it depends on the scanner, in fact, and on the tolerances you have selected. If you want to reach FATG 4 star, it's very tight, especially on the tone scale. It's plus or minus 2 RGB level. So it can change rapidly, so you may have to readjust more often. If you select here Metamorphose Light, it's okay. This scanner, we know it is very stable because the light is quite strong, so it doesn't depend on that. And also because, for example, the LED here, we use them, maybe you saw, only 20% of the power. You know, I can go to 100, it's much more light. Okay, so that means the LED will not hit a lot because they can do much more. So, and LED, what is very good in LED compared with fluorescent tube we had in the past, there is no warm up. You start and it's okay. The color and the light is always the same. But yeah, that's the main thing. It's not a big problem if you spend a lot of time adjusting, as long as the results stay stable. You can spend time, I mean, that's what we did. You don't have to do it with this one because we provide the ACC profile, but the ACC profile has been adjusted to give the best result. And something you have to do anywhere is, it's not enough, I would say, especially at the beginning, to say it's green, it's okay. Because maybe you are very close to the limit somewhere. So it's good at the beginning to check, I mean, the numbers, or at least to check, for example, here. Here it's easy to see that we are in the middle. So if there is a small change, we'll still be within the green area. If we were like we're at the beginning, very close to the top, that means it's 1 hour later it can be out. Okay. So and after that it should be stable. If not, you cannot use these standards. If it doesn't work, that means there is something wrong somewhere. So it's either you have selected something too tight for your scanner or for your scanning process. This one will be more changing because of the ambient light, we will see. For example, if we turn this light here on and off, the result will be quite different. This one will don't mind so much. Yeah, we will see also the results can depend also on the chart because there are some changing. The measurement of the chart is not so precise. So if you are okay with one chart, I'm not sure to be okay with this one. Completely, it will be a small detail, but completely. So the customer we have doing this, when they have many scanners, again, we have one customer having 15 scanners, they have one chart for 2-3 scanners, and they use it only on this one, and on the other scanners they use another chart, and they don't mix the charts, because if not, you are lost. So, yeah, and it depends also on the tolerance you want to apply. Here you see metamorphosed light, you have a wider tolerance in the dark area, because you are not supposed to scan something like this. So that makes it also more easy to reach. It doesn't matter if this level here, you can see it's in the, here you get the line. It's at the right level. But if it was a little bit higher, even plus 2.5, it's okay. If I want to check metamorphose full, it has to be like it is down to the maximum. So that means there is more possibility to have a change because of that. So that's why for your question this morning, if you have books and you know you don't have density darker than this, if you want to check metamorphose full, you will have to check up to there. So you may have an error sometime that will not affect your result, but that will make the test failing. So after it's up to you. If it's your internal test, you will look at the curve, you will say, okay, I don't mind here, it's not what I want. If it's for an external, an external company testing for you, they will have to get the right result. So they will spend a lot of time adjusting just for that. What else we'll see? Yeah. So most of the time on this, so there are some values that will not change. The shading is correctly done. It will not change for a very, very long time. The noise depends on the camera. So as long as I have exactly the same settings, the noise will always be the same, except dust again. The color, as it is an average, it should not change so much. What can change in a scanner, you can have the resolution. If, for example, on scanner, you can move the camera up and down to increase the resolution, then you have to refocus. And you can focus, your focus adjustment can be more or less good. So here you can have some changes on that, so you have to check. And the tonal reproduction can change a little bit. For example, on this one, you could scan with or without glass plate. You could scan with some different lighting settings that could change the light level a little bit. It's good to check that. And on this one, the light level really has to be checked, especially if you are not in a black room, because so there are some criteria that will be always the same. You will have exactly the same result all time. Some other you don't know really, it can change a little bit. On this one, I know the noise will be always okay, shading should be always okay, the color should be always okay, unless there is a big mistake on the tonal reproduction. And the resolution, it depends on the scanning resolution and on the level you want to reach. It should not be a big problem. So I know it's a little bit frightening, but Also, what can be done, I don't know what you are doing exactly, what you're scanning, but if you want to apply that, you can also go step by step. That is, you can start checking what level you get and try to improve step by step. Don't try to get maybe everything green the first time, because if something goes red, you will have to stop your production to adjust again. And so maybe first check just to see what result you get and how they are they stable or not? That's very important. Or are they changing? And if they are stable, you can slowly try to increase. For example, if you talk about ISO, you could start applying ISO C, which is quite easy. And if it's okay, then you can try ISO B and so on. But you have to know, at least, it doesn't matter if you are metamorphose compliant or not, but at least you have to know what kind of result you get. What is your level first? Because I don't know, maybe you don't check shading at all when you're scanning something, and maybe your lighting uniformity is not good, and you don't know. Same for the noise. Maybe because of some settings, you have a lot of noise in your image, and you did not notice. And this also is useful to prevent any mistake. This scanner is quite open. I mean, when you use it, if you have the full right, you can easily go in the configuration and change something. If something wrong is done, it will appear immediately here. That's why it's good to check that before scanning. If someone, I don't know, moves the camera focus, you will, just a little bit, I mean, you will scan, you will not notice it so much. Here you will rapidly see something is wrong. So that's why. Okay, for that, what I want to do? I have to show you ImCheck, also the simple software. Unless you have some other question on that. Again, the two things that can go wrong is tonal reproduction because of the light level and resolution because of focus adjustment or a bad setting. The other one depends more on the scanner itself. Yeah. So let's scan this chart. So I will show you. Okay. Okay, so I need to start ImCheck. It is. So this can be downloaded from no. From here, Peter Burns. So there is the software itself, and you need a MATLAB version, which is here. So here you have no setting, you just have to open a file. Not here. What is it? It is okay. No. Of course, the chart has to be straight, more or less. And then you have a specific test for this chart. And you just have to click precisely, if possible, in this cross and in this one. Here you check that this rectangle are on the edge, and you click on Go. And you get the display, the FTM display, and all the results. So here we can see we are a little bit high on this one. So that's very easy to use. You even have some misregistration information here. That is how much pixel shift you have. So this result here, you have the sampling efficiency for the red channel, blue, green, blue, sorry, and luminance. So you just look at this one. And if you want the numbers, you have the number of pair of line at 10% and at 50%. So it's easy to use. Sorry? ImCheck. Here, ImCheck. I have it. Yeah, it's higher in the PowerPoint. It's come from this. It's quite. Here we check here. This one. This one we use it quite often. I mean, it's very easy. You have just a small chart and you place it where you want, and you can check your level. So if I do, I don't know. Can try this, for example. So here I've lowered the chart is too low, so it should have an effect on the resolution. You can see. So yeah, still enough. The curve here now dropped a little bit, but I didn't went low enough. But you will, with that, rapidly see the level of your scanner. And by the way, it's also, yeah, that's interesting. If I will open again the previous image. Okay, so you see here, this is a resolution which is calculated when you click on the cross. So here we have 295. It's still okay, but that means we are a little bit low. This is also something that is checked in IQ Analyzer. You have here what they call the claim sampling rate. That is, you say, I'm scanning at 300 dpi. That's what is written in the file. When you open the file, it's written inside 300 dpi. This is a real sampling rate. So they measure on the chart that it is not exactly 300, but 299.2. That is, you check on the chart some size, and it has to be a certain amount of pixel. And this is a resolved frequency. That here it's the same because we have 100%, but if it was lower, we could have, for example, 300 dpi claimed, 299 obtained, and maybe only 280 as a efficiency. And this you get also here. So is important to check when you are using a camera on a copy stand like this, because it's very easy to move it up and down, and then you think you are scanning 300 dpi, and in fact you have 280 or something else. So this simple tool can also check that. Of course, the easiest is to take a ruler, you scan the ruler, you count how many pixels you have, and you get it also. But I mean, you get this information, and sometimes you notice it's not right, and you check, and in fact it is wrong. So this tool is nice. I mean, they keep it free, so it's good, thanks to this guy here. Okay, you still need the chart. And you can also use it like that on a single edge. So like this, so don't look at the display, but here I get the curve only from one edge. And by this way, I can use it even on another chart. So it's a chart QA62, so there is a full menu for that. But if I want to use it on the UTT, it's possible. Not so easy here. So scanning 300. You have to enter the resolution, and then so you have to select one edge. Yeah, right. Wrong. To do it again. I should crop. Maybe I can do that. Sorry. I will take only this chart from example. And call it. Okay. It will be easier. So I can. So I have to know the resolution, scanning resolution. Okay, and then I can draw a rectangle, and I get the FTM curve. And for example, I don't get this curve in this display. And sometimes it's missing. I mean, you can see many things on that. So I can get it with ImCheck if needed. Can be useful for that. That's how we find out that the edge on the UTT is not so good compared to the QA62 with a simple tool like that. Okay, so this one is free. GIMP is free also, and that's useful. With that, you can check the level correctly. You could even check the noise. If you select an area here, and I have some trouble with German, but if I find the histogram somewhere, yeah. How do you say histogram? How do you say histogram? Do you see it? Yeah, okay, histogram. Okay, just like this, I can, yeah, seems to be very low. I don't know this version. I should be able to see the, what is this unit? Okay, maybe a setting somewhere, but I could be able to measure the noise with that, with GIMP. So with that, you already have free tools, I mean, but again, it is one by one, so it takes a lot of time. It's much easier to get directly this. Especially when it is working, you do it, it's okay, and that's it. And you can keep a track of that. You have a text file somewhere, you can make some screenshot and keep that together with your production to prove that it has been checked and the result was this one. Okay on that? Is it, what is the next break? I never remember. 20 minutes, okay. So what else can we do on that? Because we can do the same on this one, but usually after the break. Yeah, if we go there, maybe. We can see when checking ISO, what is the result? So when you check ISO, it's quite similar. So with this version software, you have a warning on the dynamic range. It's just because the dynamic range, as I said this morning, is usually, not very high on reflective document. So on the chart itself, the dynamic range is not a lot. The difference between the whitest patch and the darkest one. And it is lower than the specification in the ISO 264. That means the warning here is just to say that they could not check that the dynamic range is high enough because of the chart. So here you see it's exactly the same display, only if you go on some display you have something a little bit different. But you have at least the sampling efficiency at 10% and 50%, colorimetry extension, the max modulation. The number a little bit different, but everything looks the same. The color, we don't see it, but they're using another formula. Shading will be the same, exactly. Gain modulation, tonal reproduction. Yeah, here there is no widening in the dark area. That's it, but except that there is no major change. So that means checking ISO, checking metamorphose are very, very close. Doesn't make a big difference. Only on small detail, but that's it. And bad setting, you just have this one. Yeah. And, okay. Okay, I don't know. When you use it, you have to crop the image like that. And if you crop it like this, it will work. If you give him an image like that, you will have to crop manually. And when you crop manually, you have the option to modify here one by one the position of the chart. It can happen sometime, especially with the older version of software, that the chart was not correctly detected, and you may have to adjust a little bit the place when it is where the analysis is done. But now it's usually okay, as long as the chart is cropped. Yeah, I think that's it. I cannot show you open dice because I. Yeah.
Settings to change the light, change the light. What
Yeah.
are all settings to change?
You mean on the scanner?
Yeah.
On the scanner, so it depends on the scanner, of course. On this one, sorry, I'm inside. I say it before going in because it makes some noise. You can adjust about the color. You can adjust first the light level, the level of the light here, so it will change the whole curve. About the color, you can adjust the hard red, green, blue level in the dark area and in the white area.
On the scanner line.
It's inside the camera.
Okay.
Inside the camera, it's this one here. So here we have reduced the display, but usually it's a slider. So you can, this is a black calibration. So for example, if I do this, look at the black level here, it will go up. Okay. I don't know where I was. And this will change the light level, so the white level here. If if I modify this, so it can be on the 3 channels at the same time, if I want to change the level, or it can be on one channel alone, like I did on the blue channel before. So here, if I do this, it will reduce the signal here, you see. And if I do that, it will reduce it only for one channel. So, it's already 0, sorry. Here we go. You see the red channel going on. So by this way, you can balance the 3 channel in the black area and the white area. You can move these 2 levels up and down, and you have the gamma correction for the curve. That's enough usually. Then you have the exposure time of the camera here, and the light level. So the light level will give more or less light, and the exposure time will do the same, will give like if you had more or less light. That's it. Something I can show you, which is not, so I don't want to, so here I've done many changes, so I will just reload my calibration. Yeah, I hope so. Yeah, no. What did he do? 9. Configuration, control profile. I want to load this one. Yes. No. Okay. Anyway, I will see later. I can show you something else. It's not directly image quality, but we talked about this before. Yeah. Yeah. So my setting, I'm going to read red, but you don't mind. So you see here, you have some reflection. It's possible also playing with the lighting just by clicking this and this. Fine. You see, to remove the reflection just by scanning. So here I still have a shadow somewhere but there is no more reflection by itself. So if you compare this image and this one, so you could do like that. So they are reddish because I changed the settings. But here we go. Yeah. Okay. So you can see this is just done by, changing the lighting settings. That's it. That is what we do. In fact, you cannot see it, but when scanning, we take one picture with the right lighting, another picture with the left lighting, line by line. The lighting is blinking, but very fast. You cannot see. And then we mix the 2 images to remove the reflection. So it's not image processing, it is just lighting control. And this can be used on document in a mylar like that, or very glossy document, magazine which is very glossy and that makes some reflection.
What's the difference to image processing?
No image processing,
What's the difference?
The only processing, in fact, what we do, we take the minimum pixel. We compare 2 pixels one by one, and we take the minimum one. It's not image processing. We don't try to detect any glare or something. See what I mean?
No. Me, when I do calculation, it's image processing for me.
Yeah, it's kind of image processing, but not so much.
Not so much.
It's not trying to detect what is a reflection and what is not. I don't get it here. For example, yeah. For example, this is a reflection, but it's inside the image. And this is a reflection, it is due to the scanner. So when you, where is it? Here you remove this reflection, but not this one. It's not an image processing trying to detect what is the brightness or not. That's what I want to say. So this is for, but it could be used more easily for a document like that. Sorry, like this. Right document. So it's not part of the image quality by itself, but it can help sometimes. Okay, so okay, I need to. So here, for example, like I will have to come back to my standard setting. And here, yes. So if I come back on metamorph, yeah, that's when you crop manually, you have to do like this. In fact, not like that. No, this one is too late. Sorry. So yeah, I tried to come back. You see, not completely. What is it? So the black level is probably a little bit high somewhere, on some, yeah. Okay. So I need just to lower the black level few. So if I want to know how much, it is 205, so that's quite nothing. Just need to come back here. So you see, if something goes wrong, you can come back quite fast to the correct setting. Okay, so you see, we started from this. Yep. We started from this, which was a little bit red, and in 2 scan you get something correct. So it can be quite fast when you get used to it and when you have something correct. So it's not so hard. But again, at least here you know you can really scan because everything is okay. Okay for that. So we can have a small break now and go on with this scanner. So on this one you will see there are some differences, and I will show you also the other chart. There is something to see on this chart. Okay.